So let's get started. My name is Nirav Kothari. I'm a principal consultant with professional services. I've done this quite a few times. I've worked with a lot of enterprise customers who have been through this journey or are about to start this journey. One such example being migration of Condé Nast in 2014. Right from assessment to shutting down a data center, I did it in about 90 days. 500 workloads, little over a petabyte of data, and there's a very cool video on our website where at the end of those 2 minutes they put up a board saying for sale. So why am I saying this? I'm saying this because I've been there, done that. I've heard a lot of customers' requirement, more importantly, a lot of complaints from the customers about when they embark upon a journey, something like this, something like a mass migration, a data center shutdown. It has been quite a bit of journey for those guys. And I've heard it all, and I'm going to share some of my experience outside of talking about the Application Discovery Service, of course. I'm going to share some of my experience on what happens in the field and how other enterprise customers have done that. So what we're going to do today, the agenda that we're going to cover is we're going to talk about a typical cloud migration journey. How do customers do it today? Then we'll spend some time talking about what they have told us. What have customers shared in terms of their experience, either of a complex migration or a successful migration, either ways. Think of that as voice of customers. And then we're going to spend a lot of time talking about what we announced today, the AWS Application Discovery Service. We'll try and leave about 15 minutes towards the end for Q&A. We should be able to take care of most of the questions you guys might have out there. So here's, before we talk about discovery service, I want to build up why a discovery service is important. What's the role that it plays? So here's an illustration. By no means we're going to talk about migration, of course. Doing that in next 1 hour is not going to do justice with the topic itself. So we're not going to talk about migrations. But what I want to baseline is, here's an illustration taken out of what we call as a CAF, a Cloud Adoption Framework. And if you don't know about Cloud Adoption Framework, you can go on our website and look up for CAF. At a very, very high level, it's a methodology, it's a framework that AWS professional services consultants like me have developed based on our experience working with enterprise customers. And it has got about 9 perspectives. It goes into people perspective and security perspective and culture perspective and DevOps perspective and so on and so forth. One of the perspectives out of those 9 is application migration perspective. So this illustration is really borrowed from that book. With some degree of variance, most of the application migrations kind of follow that journey. Of course, every case is unique, every workload's different. But at a very high level, that's the journey that most of the migrations do follow. It typically starts with strategy. You want to really go and define a strategy. Is it going to be my development workload first? Am I shutting down a data center? And that's a strategy in itself. Am I adopting to DevOps type culture? What am I really doing, right? So it all starts with a strategy, then gets into the planning and discovery phase where you will go identify if data center shutdown, data center closure is one of your desired outcome of the journey. What's really running in the data center? What are you really going to deal with? Things of that nature. A quick show of hands, how many people have heard about 6 Rs, Gartner's 6 Rs? Yep, a handful of them. So Gartner published this 6R strategy, or what it goes in saying is every workload will fit into one of those 6 Rs, and the Rs could be retain, retire, rehost, re-architect, refactor, re-platform, so on and so forth. So think about that planning phase to really help you go identify every workload in there, and based on the properties of the workload, such as what's the type of data, is it sensitive, is the application super complex, can it do horizontal scaling, and is it homegrown, and is it tightly coupled and loosely coupled, and so on and so forth. You will go and align during the planning and discovery phase every workload to one of those R's, right? And each R will have a follow-up strategy on what would you do if a workload belongs to a particular R. So for instance, if rehost is the strategy for a given workload, are you going to use a tool such as AWS VM import to lift and shift an existing VMware, VMDK, OVA into AWS and light it up in AWS? Something like that. And then it gets into the build and run phase. In build phase, what you're really doing is picking up one of those applications, identifying what's the appropriate R, and then executing upon that migration. You're going to light up that application into AWS, and then you'll keep doing it unless you're done with all of your applications, all of your workloads. And after each migration, when you're comfortable, when you are done through your smoke test, your UAT or FAT, so on and so forth, you will hand it over for operations. You will hand it over to the support organization to go run it, optimize it, monitor it. Think of those red, greens, and yellows, Nagios, HP OpenViews, right? So that's a classic journey of a migration. The first two phases, if you were to think about it, the strategy and the planning phase, is usually done at a portfolio level, i.e., if you're going to shut down a data center, you're going to run a strategy and a planning phase for the entire data center. You're not going to pick one workload, one server, one application, do assessment, and then classify it, and then do a migration and complete it, and then go back and pick up the second application, right? That's not going to happen. So the strategy and the planning phase usually are done at a portfolio level, and then the build phase, is done at an application level or a workload level, right? So here's customer voice. A lot of customers, we've heard a lot of customers say, cloud migrations can be complex and costly, and it can overrun, and it might need more resources, and so on and so forth, right? So some of the things that we heard in the field out there are data center migrations can involve tens of thousands of workloads, right? Some of them you don't even know, probably, right? And if I were to ask a quick show of hands, how many of you can predict what's in rack number 5 today in your data center, right? Some of you will, but it is a little complex, right? And then, let alone rack number 5 and system number 4, can you predict what's running on system number 4, rack 5, and what does it talk to, right? There's so many tentacles that go out of that system. Some of it's not documented, some of the documents not updated. Some of the tribal knowledge is gone, the application owner resigned, so on and so forth, right? So identifying, creating a meaningful inventory, is difficult, and then add on top of that, understanding all of those application dependencies quickly starts getting more and more complex, right? And then what if there's one of those legacy applications in there, right? It's very tightly coupled. If you change a DNS name of something, it might break, right? Things of that nature. So, and then the last one being, putting together an inventory, if you do it manually, right? You realize the problem, you don't have a good source of information. Most of the CMDB projects have failed, right? You don't have a good CMDB. You can manually go and identify all of this, but it's very, very time consuming, and that's where most of the effort and cost overruns do happen, right? So some of those voices from customer led us to do this. So going back to the picture, there used to be existing AWS tools to help you with build and run. For example, AWS VM import is a tool that's available that allows you to go pick an VMDK, existing VMDK or an OVA file, and drop it. Think of a tool-assisted automated migration into AWS. Or when it comes to run, Things like CloudWatch will monitor your instances. Things like AWS Config will do CMDB CI inventory management for you. Things like config rules will enforce corporate governance into your account, things of that nature. What we're doing today with this announcement is we're introducing a tool, AWS Application Discovery Service, that will help you in the planning and discovery phase. Now, there are quite a few tools from the partner ecosystem that existed in that space as well. So it wasn't a void that we're filling in. It's just that customers have been asking us to provide something that's done by AWS. It's an AWS tool, right? So partners like Risk Networks, Science Logic, I don't know if you guys have used them, have experience with them, do exist in the marketplace to help you with planning and discovery aspects as well. Let's talk about the service. So the AWS Application Discovery Service is a purpose-built, emphasis is mine, it's a purpose-built AWS tool to help you discover workloads, right? And I say purpose-built because we've seen some of the tools in the past, they are meant to do much more than discovery. And therefore, we thought we'll write up a lightweight tool, lightweight product, which is purpose-built only to assist you in your journey to migrations. What does the tool do? At a very, very high level, it does the following. First, it helps you build up an inventory of your hardware, your software, your costs running out there. It helps you map dependencies. So you got a few application stacks, and how are they interrelated? And do they have integrations built with third-party partners? And does one of those integrations go and open up a sales order in your SAP systems, and so on and so forth, right? It helps you do dependency mapping. And then the last thing it'll do is it'll help perform a baseline, performance baseline, and it'll really come handy when you perform the migration. When you do a migration, think about you doing a right sizing of an instance type. Think about you doing a performance testing at the end of the migration. So you got a baseline information that you can compare with at the end of the migration to identify whether it was a successful migration or did you lose something, did you miss the mark. So the overview of the service, the way the service is architected, two main components of the service. One on my right, your left, is a discovery agent that runs on the host. It collects information, it gathers everything that it's supposed to gather, and then over a secured encrypted connection, it'll go and populate that data into hosted database. We're calling it out as a discovery database. The agent can run on both Windows or Linux hosts. The agents will capture system information, application information, performance statistics, dependencies, so on and so forth, and it'll transmit it over. What we're doing is we're making public APIs available for you to go and query the discovery database and retrieve information that's stored for you in the discovery database. What we also allow you to do is create an export, create a dump of all of that captured data in a CSV or an XML format so that you can consume it in any other tool of your choice. Okay? One of the most powerful things that I personally like about the service, especially the architecture of the service, is that API operation. And it's a very powerful tool. It comes in very handy when you think about the agent side of the house. The way the service is architected allows you a lot of flexibility to write up your own agents. Think about one of those Sun Solaris running somewhere in your environment. You can go ahead and write up your own agent and still populate all the information captured by your own agent into the discovery database, at which point what you get in return is the AWS provided API backend, right? The analytics part of it, right? And the APIs that we're going to make available along with the launch follows the standard AWS SDK, which means all the languages that you're used to, all the bells and whistles that you're used to using in AWS SDKs are all available right from day one. Okay? What it also allows us to do is a lot of the existing partners can design their own discovery agents and still consume the rest of the existing ecosystem to consume the data that's available, that's captured by the discovery database. So let's talk about the agent. What's an agent? It's a piece of software. It's a binary that's available for you to download from the AWS website. And at that point, you can use any of your existing software management tools, SCCMs of the world, to go and deploy it across your entire environment. Okay? As I said, it supports Windows and Linux hosts. The agent, the piece of software that's going to run on your host, has a very, very small footprint and minuscule overhead. It's not going to consume a lot of your CPU resources or memory resources or anything of that nature. Okay? For the security conscious folks sitting in the room out there are two things that are very, very important. First and foremost, it's a proxy agnostic, which means deploying an agent won't require you to do any configuration or punch any holes in your firewall to allow the communication. It's an outbound communication only, which means the agent will collect information and post it on AWS over a standard HTTP or port 443. There is no inbound connection requirement, which means you're not changing any of your existing security posture. You're not punching holes in your firewalls. Number two, it allows for an offline mode. And what's an offline mode? When you set up an agent, you have an option to change the mode between online and offline. If you set up the agent in an offline mode, the agent will perform everything that it's supposed to do, but not communicate with AWS. It will capture all the information and store it in a local CSV file on the host itself. What that allows you to do is allows you to go and inspect the elements of the data that's captured from your host, verify it before you turn the switch back to online. It allows you to audit what data is going to go out of your data center or of your environment. So, for the security conscious people in the room, those two are very, very important points in the way this service is designed. What does it capture? We spoke about the CSV file, the offline mode. Here's a quick list of what it captures. It captures inventory level details around the infrastructure and the application. For instance, what's the DNS name? What's the host name? What's the IP address? What's the operating system? Is it 32-bit? Is it 64-bit? So on and so forth. It'll capture an inventory of all the installed softwares. And the second bullet really refers to COTS. If there's a known software installed on your host, it'll go ahead and qualify it, it'll capture it, and it'll make it available to you. It'll capture all the information about all the applications and processes with very, very minute details such as user information. Which user owns a particular process running on your host? What group does it belong to? List of kernel modules, operating systems, and so on and so forth. It'll capture system resource specific information such as CPU and memory and disk space and network IOs and what's allocated versus what's consumed. Think about right sizing, right? It will really influence your decision of how do you right size an instance type when you migrate it into AWS. It'll also capture, the last one, it'll also see all the TCP, UDP connections on your host. So anything that wasn't captured in bullet number 2, that is COTS, if you have one of those systems running homegrown custom application out there, or if you have one of those applications consuming a custom port, the agent will still go ahead and capture all of that information. It might not be able to correlate it to an existing known application, but it'll still go ahead and capture all outbound and inbound TCP and UDP connections. So for custom applications, we'll still be able to map it out for you and display the information back to you. The last thing on the slide, it captures NIC information, or network interface card level information. Think about some of those legacy applications where you used to run more than one NICs because one of the application is going to consume or will be licensed based on a MAC address or an IP address. So if you have multiple NICs running in a host, the agent will still be able to go ahead and capture it and display that information, correlate that information for you. Here's the one that I love, the public APIs discussion, the features of the discovery service itself. There's nothing to do with the agent alone. This is the discovery service altogether. Here are some of the APIs. For example, the first one, list configuration. If you were to consume that API or if you perform that API operation, what you get in return is a list of all the hosts, regardless of whether a discovery agent's running in there or not. Okay? So let me say that again. You deployed agent, day one, you deployed agent on a single IP address. Because, referring to the previous slide, because the agent will go ahead and listen on all TCP and UDP ports, the agent is aware of a host which is communicating with the target host. And therefore, when you do a list configuration, you get a list of, here's a workload, here's a server which has an agent running on it. But by the way, here's a server which doesn't have the agent, but it still participates in some way, right? So that itself can give you very rich information on, all right, here are 20 hosts which I need to go and deploy agents on. Or here's one of that host which is running under somebody's desk that you were not aware, but it still participates in an application group, right? The second API listed in there, get configuration attributes. This is when you know there's a host, you deployed an agent, and you need to know all about the host, such as what system resources were allocated to it. Of that, how much of it is consumed? What are the processes running on it? What users are on the host, and so on and so forth. One of the great things available is an ability for you to go create or delete tags. So the moment you identify 10 of those hosts which participate into an application stack, you can go and, using those APIs, you can go and tag all of them together. You can tag them for future identification. You can tag them for migration planning. You can tag them with the right sizing information, so on and so forth. At this point, there are about 25 tags supported. So think about you articulating your entire migration plan and putting them as a metadata in form of tags with all of those hosts. Like all other AWS services, tags are completely optional, but they are one of the most powerful things that you can consume. And this tags will apply to your on-prem infrastructure. You never had an option to do that. You can do that with Discovery Service from a migration perspective, right? So about 25 tags. And the last API call in there is export configuration. It's not a real-time online thing, i.e., if you discover a new host at this moment, and if you created a dump in the morning, the dump will not reflect it. It's kind of offline in that sense. So every time that your discovery database is rebuilt or rehydrated, you will have to perform that export one more time before you consume that information. But it makes offline analysis way too easy. You're allowed to download, you're able to do a CSV or an XML, and then consume it in whatever tool of your choice to go ahead and process it, analyze it, visualize it, what have you. Right? There will be an existing CLI, there will be an CLI SDK utility available with this preview launch to allow access to API operations. And that's one of the best part that I like about it, right? You build once, you program it once, you code it once using the existing APIs, and then you use it multiple times in multiple engagements, right? So if I do this once, if I write a small piece of Python code for a given use case, for all future engagements that fit that use case, I can just reuse it, right? That's the beauty. Think about aligning to an agile DevOps automation type culture. Very, very powerful. All right, so we're going to talk about an example. So here's an example. You got a LAMP stack. You got an existing LAMP stack running on-prem, and you want to migrate that LAMP stack into AWS. So what you typically do is you'll go ahead and discover this LAMP stack, i.e. identify every server, every workload that participates either in form of running an Apache, running a MySQL, or running PHP, which will make up that LAMP stack. So you'll identify all of them. You will try and understand what are all the external dependencies. And by external, I mean not the application itself, not the stack itself, but dependencies such as authentication or DNS, or so on and so forth. You will analyze all of those dependencies, you will right size, and you'll perform the migration. When you perform the migration, either you will do it on your own, you will have an SI partner, you will have AWS Professional Services, one of us, right? Will help you go and then perform a migration. And depending upon which R out of the 6 R's that I was referring to, your migration strategy will change. For example, in this example, they're talking about re-architecting an application. So they swapped out, they ran their Apache on an Amazon EC2. They replaced their existing hardware load balancer with an Amazon ELB. They replaced MySQL with an RDS. And they replaced their DNS with Route 53, so on and so forth. Right? So here's a classic example of how a LAMP stack will be picked up from your on-prem and moved into AWS. What we're going to do now is we're going to see how we did it using the AWS Discovery Services. So here's interesting enough, in preparation of this demo today, we spent a couple of days to quickly put a wrapper of CLI around the existing SDKs, APIs available with the Discovery Service. So your possibilities are endless with those APIs, but to align with that example of migrating a LAMP stack, and I'm going to walk you through some of these API operations. So here's the first one. I'm listing all the all the hosts by applications. And what you see on the screen is the service was able to find 6 web servers. And why did it qualify as a web server? Because there was either Nginx, HTTPD, one of those processes running on the host. And then the service was able to identify 3 database servers. Again, by virtue of MySQL process running on the host, we identified MySQL, and therefore we're listing it as, qualifying it as a database server, right? So that's the level of details that is going to be available to you. Here's another example of an API operation. I issued a very simple operation called as list me a stack, which is LAMP, or list me every host that participates in a LAMP stack. And to qualify to be a part of LAMP stack, again, it's running Apache, it's running MySQL, it's running PHP, one of those. And then you will see in the response, what I got back was, here are some of the machines which are running Python, and then here are some of them which are running Nginx, and then here are some of them which are running MySQL. Okay? Still, the service is not, the operation is not giving you a clarity on which of those hosts make up one application for you, right? It's just doing it at a raw level. It's just clubbing them together, qualifying them or filtering them based on the LAMP stack policy, which is, do you run Python? Do you run HTTPD? Do you run Nginx? Do you run MySQL? If you do, go ahead and list them. Okay? So what we did was, on the first instance, on the first CLI on the top, what you see is, imagine a situation where I know only one host, which is a part of an application group. What I did was I listed all the dependents, every host that is talking to this target machine. Go ahead and list them. In return, what I got was, there is this host with IP address 246, ending in an IP address 246. That's the only machine that talks to the target host. So I performed a similar operation on 246 to see are there other instances participating in this application stack. And in return, I got 222. So I can keep doing this without knowing what's made up, how many hosts are participating in a given application stack. All you need to know out there is one of those hosts. And you can go ahead, query the service to build up an entire application stack without you going to have to interview the application owners out there, asking them to provide you a list of what's your prod and what's your dev, tell me what hosts, right? You're never going to get a response, right? Most of you have done this, right? The day I send out a template to a customer saying, hey, fill out your inventory information, that Excel sheet's never coming back to me, right? What if there is a non-intrusive way for you? I see some of you laughing in there. What if you had an automated way, a non-intrusive way to go query the system and ask the system, hey, tell me who all is talking to this host, and you building up a stack information, right? That's the power of API. And the last API over there is, as soon as I identify all of those hosts which participate into that application stack, I just go and tag them, all of them together as wave one. Think of that as wave one for migration, right? Here's my wave one of migration. It is going to have all of those hosts which are participating into a LAMP stack, okay? As I said, you can have 25 tags out there. You can go to the level of saying, here's my wave one of migration. My wave one happens on 26th of April. My wave one should involve the following application owners. My wave one should happen on Saturday. Whatever you want to go and do with tags, you can go ahead and build out a migration plan in a metadata format using tags. Okay? Here are a few more examples. So once I tag and once I'm supposed to go ahead and execute the migration, I can go ahead and list all the hosts that have similar tag. Okay? I can query the service to list me all the hosts. In the second example over there, what I'm doing is I'm drilling it further down to now do right-sizing type decisions. So I'm listing out, or I'm doing a detailed describe on all the hosts that participate or that has a tag as wave one. Okay? There's much more information that's available in output. We just did a screen grab to drive the example to make a point that how can you consume information that's already available to either do migration decisions, to do migration planning, to do right sizing of instance types, so on and so forth. So how is the service available? We announced the service today. It's available if you were to go on the AWS website. It's available for preview starting today. You can go and sign up. What you would need to do is the service is made available only through AWS professional services or SI partners. Okay, that doesn't mean you're going to spend any extra. But what it means is if you were to have any need of troubleshooting, any kind of help, one of them will be available to help you with your discovery service. So the way it'll work is you will go online, you'll go on our website, and then you'll fill out a form with your contact details. In the back end, depending upon your size and your region and the closest available partner or professional services consultant and so on and so forth, we will go ahead, assign a consultant to you, and the consultant will, at that point, start driving whitelisting of your account into preview and so on and so forth. So from your perspective, all that matters is you can go online right now, fill out a form, about 5 or 6 fields, and that's it. We'll get the ball rolling for you. What I want to show you in the next couple of slides is a slightly different view, perspective of the service itself. So here's a visualization example of the service. The tool is some open source tool. I don't even remember the name. It's some open source tool. What I did was for this demo, for this mock, we exported the information in a CSV or an XML format. In this case, it was a CSV. we imported that CSV data into this open source visualization tool, and then every API call that you were making on a CLI or through the SDK, we did that API, we did that filtering into the tool. So if you look at, pointer works? Doesn't. If you look at your left, you'll see a query over there which says, list me every host in there which has a source port, which has a source as Python and destination as Nginx, right? At that point, no matter what hosts are there, it'll go scan the entire CSV file or your entire environment, so to speak, and highlight, those yellows are the highlights, or there's a text output at the bottom of it. That's not important though. What's important is you're able to submit a query and visualize your entire addressable migration on a single screen, right? To give you another example of the same thing, here's a zoomed out, no, what is it, zoomed in? Here's a blown up version. Here's a blown up version of one of those previous screens. What it's showing me is all those yellow circles, ovals over there are the highlights. Okay, and that's really the functionality of the open source visualization tool. What's important is there are those 4 hosts which meet the criteria, i.e., the source is Python and the destination is Nginx. What's more important is there is one of those greens somewhere in between. Now that host doesn't really qualify to have source as Python and destination as Nginx, but nevertheless, it's a critical host that participates in the functionality of the application because it's talking to everybody in there, right? Or if you see those red lines between those 2 yellow oval shapes, that indicates there is an active communication between those 2 hosts. Or if you see one of those pink triangles, that's saying that those triangles are hosts which participate, which communicate with your filtering criteria, but they don't even have an agent running in there, right? So it's a very, very powerful way for you to, when you start thinking about migrations, when you start thinking about planning a migration, it's a very, very powerful way for you to go and identify what exists out there, right? How do they make up an application? How do they participate in running an application? What are some of those hosts that are running under somebody's desk you don't know of, but they still are a part of the application stack, right? That brings me to my last slide. Being an engineer, I just wanted to kind of close with that. The service provides a set of public APIs. The way service is designed, it uses a lot of open data format, making it very, very easy to either integrate with the service or for the service to coexist with anything else that exists in your ecosystem, in your environment. So to give you an example, it can very well integrate with discovery tools that can publish information. So the example I was talking about, risk network, science logic, the tool can coexist. They can populate, they can use their agent. You can use one of those agents to populate the discovery database. Any existing migration tools that you've heard of. I'm sure you guys have heard of RESTME and Cloud Endure and Cloud vlogs and a lot of them available in our partner ecosystem. You can use AWS Application Discovery Service to complement those tools. You can feed the rich tagged information, the rich context information to these migration tools to do an automated tool-assisted migration into AWS. Or you can use it with existing migration frameworks. Think about existing SIs. They might be using their cloud migration frameworks, right? Talk about Accentures and Cognizance and Second Watch and so on and so forth. All of these partners have their own methodology of performing a cloud migration. The tool will complement their existing cloud migration frameworks. Even if they would have built automation in performing migrations into cloud, into AWS, the tool can pretty much coexist with those existing frameworks to assist in performing migrations. That's all I had. Open for questions. Yeah, if you can please, because you're going on wire, so you can't.
So I think something like this is really interesting, even if it comes down to like how are you mapping like a microservices architecture. Can you talk a little bit about maybe the use case where it's not just specifically used for migration, but like let's say, do you envision people running this on their AWS infrastructure, for example, and then if it's going to go that far, how are you going to represent things like S3 or SQS in terms of how you'd maybe map that out?
Absolutely. So at this point, as I said, the service is purpose-built for migration into AWS. So there are not a lot of use cases that are supported. Having said that, the service in preview today will support instances like Amazon Linux. So we highly encourage you to sort of sign up for the preview. One of the asks, as a matter of fact, is for all of you to go sign up for preview, break the service, right? Break the service, help us rebuild it in preparation for GA. So yeah, a very good use case. It supports Amazon Linux as an operating system, but it's purpose-built, for a specific target.
Hi.
Hi.
The tool, especially the API, is really cool, but the problem with all the familiar names like Risk, Racimi, Cloud Endor, and this, are how do you actually get it into your target data center? I know that you tried to minimize all the dependencies and the connection requirements, but in corporate environments, like outbound is not guaranteed, or there may be 30 firewalls in your way. There also might be outbound proxies.
Absolutely. Absolutely.
It's not agentless, it's agentful, and I'm kind of wondering how you decided to pick that route versus the other one. But because it's an agent, how is it actually gathering the information? Is it using like SNMP or WRI, or is it using local things to the host? One of the problems we have is we don't have shared community strings that we could go use. We would have to go create them first.
Yeah. So the third part of the question is really going to put you in competition with me, how the agent works. So I'm going to skip that question. Given the type of the forum we have, we can definitely talk to you offline. But there were two other parts of the question. First being, there could be 30 firewalls, or there could be a proxied environment out there. How is the agent going to deal with all of that, right? So, and the agents are, I might have said it in one of my slides, the agents are proxy agnostic, which means forget about the agent. If the host can go outbound on 443 using a proxy, the agent will do it without any additional configuration. The agent in itself doesn't have an option for you to go and put a proxy setting in there, right? So it'll pretty much rely on the underlying operating system. If your host can go out using a proxy, the agent will go out using the proxy. No change in configuration. It'll use the same proven, secured, audited, firewalled environment. First. The second part of your question was, why did we pick agent-based and why not agentless or whatever it is, right? So yeah, there are use cases in favor of both of them, right? We heard customers talk about a need of having a much richer data, and therefore we thought of building out an agent-based system. But that doesn't mean that an agentless system is bad either, right? There are customer use cases out there which require a less invasive, they want to play it safe, they want an agentless system. So definitely thoughts welcome. We can take that as a feedback and obviously include it in roadmap. We can definitely do that.
I have plenty more questions.
You have plenty more? Can you take a pause and we can take one more question from him, and then obviously you're welcome.
Capturing a point in time, or is it actually looking back at, like average utilization on CPU and RAM?
Absolutely. The agent itself, when online, will send information, will capture information, and populate the discovery database every 30 seconds. So if your business cycles are for 3 months for a given application profile, let it run for 3 months, and we'll give you min, max, peak, valleys, averages, all of the above, with timestamps.
Thanks.
You're welcome. Back to you. Oh, okay.
So you said it works on Windows and Linux. Do you qualify AIX as Linux?
We qualify what?
AIX as Linux?
We qualify it as a slightly different type of Linux.
As in, you think it works or it doesn't?
A very short answer is no.
For Windows, does it work all the way back to Windows 2000?
Let me. So I don't have a good or a bad answer for you. But what I'll definitely ask you to do is, as we get closer to GA, we're going to make that announcement. So stay tuned.
Do you have a good guess on when GA will be, or any guess?
No, no. It all depends upon all of you sitting in the room here. The sooner you break it, the sooner we fix it, the sooner we go live. So please go break it. When you're laughing, I'm like a little scared.
No. I want to understand more clearly, if I have sort of multiple LAMP stacks on the same VM, is this going to be able to differentiate that there's this particular instance talking to this particular database and some other host, and there's another one, or is it basically saying all in the VM, it just lists everything that the VM's connecting to?
No. So if you look at one of these examples, one of the first examples here, it's going to list everything. If you only filter, or if you perform an API operation to only filter a LAMP stack definition, it lists just about everything. If you were to go and do individually, pick up a host and see what's dependent, what's stacking, you can nail it down to one stack versus the other stack.
Right, and so can it so if I have two Apaches running, I probably wouldn't, but let's just say for the sake of argument I did, and those things talk to two different databases on other hosts, would it be able to say, here's LAMP stack number one, and here's
Yes.
LAMP stack number two? Would it look aggregate as, okay.
Yes, it will be able to go ahead and say that.
Okay, and if there was a virtual host with one Apache thing, is it sophisticated enough to see that I see you have two LAMP stacks under the same Apache configuration? And
We'll still do that.
okay, great.
Could you just talk to how the product would be priced? Is it per system? Just give some details, not maybe.
No,
pricing.
unfortunately
How
not.
is it priced?
So at this point, I don't even know if internally we have that nailed down, right? So that information is not available at this point. But then again, stay tuned. As we get closer to the GA, we will go ahead and share that intel with you guys. Sorry, questions? We can do a target practice, I'll be like. Yeah, if there are no more questions, I think we're done. Thank you so much. Once again, yeah, sorry. Please.
What if you have things that aren't computers that you can't necessarily install the agent on, like a Google search appliance?
So the way it'll work is we'll still go ahead and identify it as a participating host, which has a unique IP address, which is communicating to an existing host, at which point there may not be an option to go and deploy an agent because it's an appliance, right? But we'll still go ahead and identify that for you. So you can go ahead and understand there's a dependency, and then you'll have to somehow deal with the dependency when you perform a migration. Thank you. You're welcome. Thank you, guys.